Hi, everyone. Welcome to today's webinar. We are going to get started in just about a minute. So thank you for being here today. Hi, everyone. My name is Lori Peak, and I am the principal investigator for the National Science Foundation supported Converge facility, which is headquartered at the Natural Hazard Center at the University of Colorado Boulder. It is my great pleasure to welcome you to the Converge webinar series. Please note that this webinar is being recorded. The captioned recording and slides will be posted on the Converge website at converge.colorado.edu. Should you have any questions or comments during the webinar, please use the Q&A box or the chat box. If we are unable to respond during this brief webinar, we will provide and post written responses on the Converge webinar webpage for this session. Today, during this brief 30-minute webinar, you are going to hear from the leaders of the NSF-funded Nearshore Extreme Events Reconnaissance, or NEAR, Association. The goal of NEAR is to conduct rapid pre-storm site characterization and to deploy instruments to collect perishable data needed to address key hypotheses about storm impacts on coastal areas, including interactions and feedbacks between the natural and built environments and human actions and reactions. NEAR is committed to interdisciplinary collaboration, and in that spirit, you are going to hear today from 6 talented researchers, including NEAR lead Britt Rabenheimer, who is a coastal oceanographer and senior scientist at Woods Hole Oceanographic Institution, Jim Chen, who is a coastal engineer and numerical modeler, as well as professor at Northeastern University, Steve Elgar, a physical oceanographer and senior scientist at Woods Hole, Holly Michael, a coastal hydrogeologist and professor at the University of Delaware, Laura Moore, a coastal geomorphologist and professor at the University of North Carolina at Chapel Hill, and Nina Stark, who is a coastal geotechnical engineer and associate professor at Virginia Tech. Before I turn this over to today's presenters, we wanted to underscore that the NEAR Association that you're going to hear about today is part of a much larger ecosystem of NSF-supported extreme events, reconnaissance, and research networks. At present, the National Science Foundation has funded 7 such networks that are dedicated to geotechnical engineering, social sciences, structural engineering, operations and systems engineering, sustainable material management, interdisciplinary science and engineering, and nearshore systems. If you are interested in learning more about these various networks and getting involved, please visit converge.colorado.edu/research-networks. Now, without further ado, I am going to stop sharing my slides, and I am going to turn the slide controls over to today's presenters. So Britt, do you want to go ahead and start sharing your screen? And Britt, it looks absolutely perfect. It's in full screen mode. I'm going to go on mute and turn it over to you. Thank you, Britt.
Thank you, Lori, and welcome everybody, and thank you for listening to this brief overview of the Nearshore Extreme Events Reconnaissance Association, or as Lori said, NEAR, which is a group of researchers working together to try and understand the impacts of extreme events along US coastlines. And the image that you see here is of Hurricane Dorian last fall approaching the tip of Florida. And the images to the bottom right are of Green Turtle Key in the Bahamas before and after the passage of Dorian. And this area was heavily damaged owing to a combination of strong winds and flooding owing to ocean inundation and heavy rainfall. More recently, we've seen the impacts of Tropical Storm Cristobal and Hurricane Isaias. And to understand impacts of events like this, we need to understand the interactions between a wide range of processes. So starting on the left, we want to understand the interactions between ocean processes and the land that lead to erosion, or as shown here, to more accretion than we really want. We also want to understand the interactions between winds and structures and ocean processes and flooding processes. And during heavy rainfall, there's overland flow and storm drainage into estuaries and rivers, carrying pollutants that then discharge out into the oceans and affect the biota and flora in the oceans. And we want to understand the interactions between all these processes that are shown in a color satellite image in the bottom. We also want to understand interactions between the underlying geology and geotechnical properties of the sediment, possibly groundwater seepage and rain and ocean processes, and of course the infrastructure in coastal areas that all result in damage and change to these systems. And in the Arctic, interactions between the thermal properties of the atmosphere, the ocean, and the permafrost that affect the coastal evolution during events. And of course, all these processes affect communities' responses to extreme storms. And then the management decisions made by those communities affect the long-term evolution of the coastal area. So for instance, in a photograph shown in the top right here, this road was undermined by ocean surge and waves and scour during a nor'easter. But the long-term resilience of this community is going to depend upon the decisions that they make about whether or not to protect this road in the future by deploying hard infrastructure or nature-based infrastructure, or possibly relocating the road to an inland location. So we're trying to take a system approach to understanding these processes, as shown in the schematic at the bottom. So this includes the water bodies, the oceans, the estuaries, and the rivers, the land surfaces, including the flora, the fauna, the built environment, and the human residents, the atmospheric processes, and also the groundwater processes in the aquifer underneath the land. To do this requires a network of many different researchers in different disciplines to understand the interactions and feedbacks between processes, which I've illustrated here in what I call a spider web plot with the red and blue lines representing interactions. We believe that to do this requires a national network of researchers in different disciplines to enable teams of collaborators to respond rapidly to impending events on any US coastline. We also think it's very important to organize a network with other groups that are responding to similar events so we can leverage our efforts. To develop this association, we held a NEAR development workshop last August in which we had researchers spanning a wide range of disciplines and career stages in both academia and federal agencies working together. This development workshop, the participants developed our vision and mission statements, which are written here. Our vision is that we can improve the resilience of the nearshore system by obtaining and sharing observations during extreme events, before, during, and after, I should say, extreme events, in order to understand the natural system processes and interactions with the built environment and with societal reactions and actions. And our primary focus is on coastal storms, but we defined extreme event more loosely to include any shock to the nearshore system that caused a rapid change system-wide. Our mission then is to obtain observations that otherwise would be lost before, during, and following an extreme event. And because they'd be lost, we consider them perishable. And they'd be lost because our philosophy is that in order to understand the end state of the system after an event, we need to understand what the system was before the event and how these processes cause the evolution of the system during the event. We also consider our mission to entrain a broad community of researchers and to coordinate and organize interdisciplinary teams to understand these processes. During the development workshop, we set guidelines for the association, including internal and external communications, with internal communications between team members primarily being via design safe Slack channels. We also consider the external communications very important. So we are expanding our communications with the other NSF-funded extreme event reconnaissance groups through Lori's Converge facility and a leadership core. And we're also working with other organizational partners and federal agencies. So we attend the USGS Storm Team meetings. We have enjoyed working with other groups doing wind engineering and coordinating with NOAA and other agencies so that we can leverage each other's efforts. We don't currently have funding for training, so our training primarily focuses on in-training emerging members onto teams. So for instance, we had an undergraduate join a team that responded to Tropical Storm Cristobal. We also are benefiting from a lot of training being provided by Converge, and I encourage you to visit the Converge website to look at those training options. We have guidelines for safety of our members, both educating emerging members about some of the difficulties of working in an area that's being devastated by an extreme event, and also making sure that our communications within teams are ethical and that we have good communications with the communities we're going into because they're being impacted by a potentially devastating event. Regarding dissemination of data, we have a broad group of people collecting a wide range of data types. So we have a strong emphasis on making sure that metadata gets out rapidly following the event, explaining who collected what, where, and when, so people who did not participate in the teams or in the event can contact the data leads to discuss preliminary observations and also potentially to collaborate on pre-quality controlled data. The fully quality controlled data would be made available publicly as soon as possible via Design Safe CI. And then we're leveraging our collective experience by having our experience with doing field work and also with our coastal communities that we're familiar with. So we're trying to collect information from all team members about field sites that they are familiar with that might be impacted by a future event, so that we have information on hand now about some of the key questions that are important during extreme events at that location, who the local contacts are, the local researchers, emergency management, logistical information, and community demographics, so we understand the community that would be going into. And again, we're benefiting from participating in Converge and with the other extreme event organizations. And together we're trying to develop agreements with some communities in order to improve access and communications during the event. So benefits of membership, benefits are participating on these field teams or home teams with logistical support and travel support. And in particular, the home teams will provide a lot of logistical support while another team is in the field, helping finding hotels, helping looking at social media for what sites are being impacted. There also is a benefit of interacting with this interdisciplinary group in order to brainstorm new ideas for future proposals and collaborations. And there's a benefit of having access to this data before, during, and following the event that could become the basis for future proposals to NSF for rapid response or future proposals to look at the recovery of the system now that you know the starting point. As such, we do not have funding for salaries or data analysis. However, we expect the data we collect to form the basis of funding for those activities. In addition, we don't focus on individual teams studying individual processes within a single discipline, but rather the system-wide response. We are, of course, responding and adapting to COVID-19. Many of our members have reduced travel owing to personal concerns or university restrictions, or just to avoid harm to a community that's dealing both with a devastating event and a pandemic. As such, we're focusing more on small teams of local researchers deploying. This could include consecutive deployments by several small teams focused on different disciplines so we get that interdisciplinary focus, or on sharing instrumentation so that one team deploys instrumentation for several different groups. In addition, we're expanding our abilities with virtual and remote measurements, which could include collecting publicly available observations and imagery from social media and using big data techniques to analyze it, doing phone and internet-based surveys, or using remote measurement techniques such as satellite and aerial imagery. And we strongly encourage and welcome new members in any discipline to join. We're trying to build a national network, but these are areas in particular where currently we lack expertise. Lastly, during this period of time, we are working on expanding our network, including both on the local, regional, and national scales with different organizations that are involved in coastal processes and coastal management. So you've heard from me now, and you've heard from Lori. We would like you to hear from the other members of the steering committee to understand why they think NEAR will benefit our understanding of extreme storm or extreme impacts on coastal communities and coastal environments, and why they feel it's worthwhile to volunteer their time to lead and participate in NEAR. So I'd like to hand this over to Nina Stark.
Thank you, Britt. My name is Nina Stark, and I'm a coastal geotechnical engineer at Virginia Tech. One of the aspects of NEAR that I'm extremely excited about is the collaboration with experts and researchers from other disciplines and backgrounds to solve these big challenges associated to extreme events in coastal environments together. NEAR offers inter and multidisciplinary collaborations within the NEAR Association, as is also reflected in the diverse backgrounds of the NEAR members, as you're just hearing about, but also through NEAR's integration in the Converge and NEAR family. To illustrate the importance of inter and multidisciplinary collaboration, I've included here two photos that we collected actually during two GEAR, being the Geotechnical Extreme Event Reconnaissance Association missions after Hurricanes Harvey and Irma in 2017, with teams that did integrate also coastal engineers and scientists into the geotechnical expert teams. My own research here is focused on the scour aspects visible in both images, the scour at the beach foundation, at the foundation of the beach house on the Florida Keys in the upper image, and the scour runnel parallel to the seawall down here in Surfside, Texas in the lower image. However, in both cases, in addition to the geotechnical aspects of sediment properties and scour processes, local hydrodynamic conditions such as surge, waves, and currents, as well as local morphology are of utmost importance to understand what is actually going on. Furthermore, structural aspects to the beach houses, as well as infrastructure such as the seawall and adjacent streets, will govern impacts of the scour to local communities with relevance for emergency management, socioeconomic impacts, and community resilience. So I am really excited to increase my inter and multidisciplinary collaborations and achieve new insights and knowledge through them and the work with NEAR. With this, I'm handing it over to Laura Moore.
Thank you, Nina. As a coastal geomorphologist, my work focuses on the large-scale, long-term evolution of barrier and dune systems, and I use a combination of observational and modeling approaches to understand feedbacks in the coastal system, for example, between vegetation and sediment transport processes, and between human and natural processes. So I'm especially excited about the potential NEAR provides to improve models and model parameterizations that will assist us in better understanding the long-term evolution of barrier and dune landscapes over time. For example, pre- and post-storm surveys of beach and dune morphology and vegetation can allow us to improve models that address the full cycle of dune erosion during storms and recovery afterwards, allowing us to do a better job of predicting how quickly overwashed areas such as the one shown on the left can recover to a more protective dune, such as the one shown on the right. Also, in addition to quantifying and assessing scour in the vicinity of buildings during storms, as Nina mentioned on the previous slide, in other areas, NEAR provides an opportunity to address aspects of interactions between the natural and built environments that have to do with overwash. For example, as a geomorphologist, I'm interested in quantifying the effects of buildings on overwash delivery to island interiors. This is important to understand because when buildings effectively filter overwash, they prevent islands from building elevation and therefore make the landscape on which communities rely more vulnerable to sea level rise and storms. So in the context of NEAR, there are opportunities to study this and other aspects of coupled natural human dynamics in the coastal system. And I'm hopeful that social scientists interested in understanding these types of interactions and assessing the impacts of storms on socioeconomic aspects of the system will be interested in joining the network. And I'm also excited about the potential for NEAR to connect through its members to other groups and organizations with complementary goals and interests. And I've shown on the right here a few of the organizations I'm involved with, such as the LTER program and the Community Surface Dynamics Modeling System. I see leveraging complementary efforts like these as a great way to extend the value of NEAR data and the range of disciplines involved. And now I'm handing off to Holly Michael.
Thanks, Laura. I'm Holly Michael. I'm a coastal hydrogeologist at the University of Delaware. I'm really happy to be here today and also happy to be a part of NEAR. As Nina and Laura both mentioned, and I'm excited about the potential through NEAR to collect many types of measurements at the same place and the same time during storms. I think this is the only way to really understand the couplings in complex coastal systems, and it's an opportunity to really make a major step forward in our ability to predict it in the future. I'm a hydrogeologist, so I'm interested primarily in feedbacks between groundwater and the other various aspects of coastal systems. Of course, the surface hydrology is one aspect, and what I'm showing on the right is an example of an experiment that my group did with Jack Paleo, who's a surface hydrodynamicist on a beach. This was just over tidal cycles, not during a storm, but I think it's just an example of taking measurements in more than one discipline. And so at the top, the photos show our instrument transect in the swash zone, where we're making both surface and subsurface measurements. And the bottom shows, the animation shows those measurements. So the colors are subsurface saturation, that dashed line is the groundwater table, and then the solid lines show what's happening in the swash zone. And so from this, I think we got some exciting new insights about infiltration and exfiltration in beaches, but that we wouldn't have gotten just from subsurface measurements alone that I would have made. But I think, you know, there's so much potential to learn more about beach systems like this one and many other coastal settings if we expand this set of measurements to include, for example, feedbacks with groundwater feedbacks with sediment transport, with the geomorphology, biogeochemistry, quantifying fluxes of water and solutes and sediments between land and sea, looking at groundwater feedbacks with ecosystem change. So I have a picture here of a ghost forest and wetland migration. And of course, as the others have mentioned, looking at the feedbacks with the human systems in management and decision making. And I'm particularly excited to work with social scientists through NEAR and potentially develop, like Laura mentioned, coupled natural human systems models that are driven by the broad array of data that are collected. And I think that's really the way forward in being able to predict the future evolution of these complex systems. So I'll stop there and I'll hand it over to Steve Elgar.
Hi, I'm Steve Elgar. I'm a physical oceanographer at Woods Hole, and I'm pretty excited to be part of NEAR because I think by collaborating, all of us can answer questions that we can't do just by ourselves. As Laura mentioned, that beaches, as we all know, beaches undergo tremendous erosion during storms, but as Laura mentioned, they tend to recover afterwards. There's a couple of examples of this, and it's something I'm interested in. The figure on the left is a sequence of cross-shore beach profiles going from the beach to offshore on the right, showing the location of the sandbar, and you can see it moves offshore during storms. That's the red arrows, but it comes back slowly after the storms. Similarly, if you see looking at the photographs in the middle, you see the sandbar might be nice and long and straight before a storm or maybe during a storm, but the sand maybe gets mobilized, and after the storm, when the waves are much smaller, it develops these really intricate patterns. In order to study that, I can't do it just by measuring waves and currents, which is something I can do. I need to work with people like Nina to understand the geotechnical properties of the sediments. And similarly, Nina needs to know about the waves and currents for her work. So hopefully we can do this together. Same thing goes for people that are working on groundwater. As Holly just mentioned, she needs to know what the water levels are in the ocean, which is something I can provide to her, and we can collaborate and do things that we couldn't do by ourselves. Similarly, Laura is interested in both the erosion and the recovery of dunes, and some of the measurements that I'm interested in making would fit in very nicely with Laura. So I'm pretty excited about NEAR. It offers lots of opportunities for collaborations, and I'll let you listen to Jim Chen tell you about his views.
Thank you, Steve. I'm Jim Chen, a coastal engineer from Northeastern University. As everybody said, I'm also very interested and very excited about the opportunity to collaborate with members of NEAR and also other EAR networks. I'm going to give you an example of how NEAR enables and facilitates collaboration. Tropical storm Cristobal made landfall in South Louisiana in early June this year. Before Cristobal entered the Gulf of Mexico, NEAR actually assembled a home team and also a field team led by Naveed Jafari, who is a geotechnical engineer at Louisiana State University. So the home team worked closely with the field team to develop and execute a deployment plan. Equipment and sensors were shipped from the home team to the field team, and also from an SF RAPID facility in Seattle. 3 days before Cristobal made landfall, the field team successfully deployed an array of sensors using airboats in one of the wetlands in South Louisiana. And then 1 week after the landfall, the field team returned to the site, retrieved all the instruments, and also surveyed the damage caused by the storms. The 9 wave gauges deployed along a cross-shore transect over mudflats and marshes show that waves generated by Cristobal actually were completely dissipated by the wetlands over a very short distance. So the data, hydrodynamic data, ecological data, and geotechnical engineering data are being analyzed and will be made available to the general research community. Now I'm going to turn over to Britt.
Thank you, Jim, and thank you again for everybody for listening to us. And I really hope you consider joining and becoming a member of NEAR. And to do that, the website is given at the top of this page. There's also a QR code. If you go to the website, you just need to click on the Join Us to become a member. I also want to thank the NSF program managers who have made NEAR possible, and our collaborators within Converge and the other extreme event organizations, as well as Design Safe and Rapid Equipment Facility, all of whom provided us a lot of advice as far as getting started and getting organized and participated in our development workshop. So thank you. And again, I really encourage people to consider joining us. Thank you. And I'm going to turn it back to Lori.
Thank you so much, Britt. And also thank you so much to Nina and Laura, Holly, and also to Jim and Steve for the presentation and for giving us such a clear overview of what NEAR has already accomplished and also where you're going. And so thank you so much. And to all of the webinar participants out there, if you have any questions or comments for the NEAR group, please feel free to go ahead and put those in the chat or the Q&A box. Or of course, you can just go to the NEAR website and follow up there if you are interested in joining or contacting the NEAR leadership or otherwise getting involved. But in the interest of time, what we're going to do is we're going to go ahead and close out now by, again, thanking the National Science Foundation for the support of this webinar series and the support that's making all of these other collaborative activities that you started to hear about today possible. And on behalf of the entire NEAR team and also the Converge team, we want to offer a special thanks to all of you who joined with us today. And finally, in closing, we hope that you will please remember that the recording of this webinar, as well as the slides that the NEAR leadership showed, will be posted on the NEAR webinar page at converge.colorado.edu. And we also hope that you will sign up for updates and alerts at converge.colorado.edu/sign up. So you can hear about future webinars, but also many of the free resources and other activities that are being developed for the research community and in collaboration with so many of you. So please contact us at converge@colorado.edu if you have any questions, comments, or suggestions. And with that, we just again want to thank Britt, Steve, Jim, Nina, Laura, and Holly for the outstanding presentation. And we hope that all of you please stay safe, have a great day, and please remember to take care of yourself and others. Bye, everyone.
Thank you, Lori.
Thank you, Britt. Thank you.
Thank you, Lori.
Thanks,
Thank
Lori.
you, Steve. Thank you.
Thank you, Laura.
Thank you.
Thank you, Lori.
Thank you. Good luck.
You well.